Hello, welcome back. And so now we're going to go ahead and move on to analog to digital conversion. And boy, this is an important thing. Notice I have removed, for the moment, the L293D. The reason being is I want all 8 of these LEDs at my disposal. Eventually, we're going to cut this in half, and we're going to use just 4 of them, and I'll show you how to do that, obviously. But I wanted to show you the full spectrum of data that we can get from the analog. Actually, I shouldn't even say that, the full spectrum. We only have 8 bits here, 8 LEDs, but this processor here is capable of a 10-bit A to D conversion. So what's going on? Well, I've added a couple of circuits. I've added a rather crudely, I might add, because I'm going to rip this out when we put feelers or vision systems on the bottom. I've added a wire here, which goes to A0. Okay, this is hooked up into the connecting point between a fixed 10K resistor here, which is hooked to the positive bus, and a photoresistor here, which is hooked to the negative bus. So if we look at it in circuit-wise, what we're doing is we're creating this. All right. So this would be my positive bus. My positive electrons are flowing through here. Now electrons love to take the path of least resistance. So if R2 is really low, there's hardly any resistance, those electrons are going to go zip, zip, zip right to ground. Okay? Easy path. Now, which means hardly any electrons are going to take this path. All right? Over here, by the way, is my microprocessor. It's sort of counting the number of electrons that take this path. So if this is a high resistance, then more electrons are going to flow this way. If this is a very low resistance, then more electrons are going to skip this path and just go straight to ground. Okay? So that's how we can take advantage of a voltage divider to actually calculate the change in resistance. Now, let's look at our thing. The photoresistor here, you can see as I watch these LEDs, as I move my hand over and start darkening the light, the values go higher and higher and higher. All right? What's happening? Well, look at this code. Very simple. I've declared a integer, a value that's going to hold the reading from my analog port. All right. This is pretty much the same as you've seen already. So I have to have all of these set for output. Remember, these 2 are set for transmit and receive. So 6 of these from port D are set for output. And then I'm stealing the lowest 2 bits from port B for making my 8 LEDs. And what I'm going to do is I'm going to take and I'm going to fill up my variable value by doing an analog read of port 0. Because remember, this yellow wire is connected to A0. Alright? So it fills up with electrons. It says, whoa, how many do I have? Alright, and if it has a value, say 200, okay, it's going to now display that value on this set of LEDs. Keep in mind, the processor itself is able to do 10 bits of resolution, but I've only got 8 bits of display. What am I going to do? Well, the easiest thing to do is simply to shift this these 2 greater than symbols, means to shift. I'm going to take and just drop off, just get rid of them, the lowest 2 bits. They're probably, you can see how these are flickering already right here, right? Okay? You can imagine the 2 that were even smaller than that are flickering just as fast, if not faster. They're undecided, they're ambiguous. So let's just get rid of them. Let's just drop it from the thing altogether. So we're going to shift everything by 2. And so value is going to be shifted by 2. Get rid of the 2 lowest bits. Let's just look at the 8 greater bits. And of those 8 greater bits, if it happens to correspond to the lowest bit, well, let's light up LED 2. If it happens to correspond to the second lowest bit, well, let's light up LED 3. Okay? On and on down the line. So as I change the amount of resistance, it changes the path of the electrons. And as the electrons are forced to take different paths, it then correspondingly measures the number of electrons that go through. Okay? So hopefully that's useful, and keep in mind that when we get our robot actually going, we're going to be keeping these 4 right here to indicate the direction of our L293, and we're going to use these 4 as an output for our display. So hopefully that was helpful, and I'll see you again shortly.